Hey everyone, welcome back. In this video, we'll discuss Python data types and conversions in depth. So now, you're going to learn more about the values that your variables can contain. As you've learned, text written between quotes in Python is called a string. Programs need to manipulate data, which can come in a lot of different forms or types. These data types include strings, integers, and floats. First, a string is a sequence of characters and punctuation that contains textual information. Strings are instantiated with single or double quotation marks, or the string function. This is an immutable data type, which means the values can never be altered or updated. An integer is a data type used to represent whole numbers without fractions, and float data types represent numbers that contain decimals. Most computers understand when you tell them to add two integers or add two strings. But generally speaking, computers don't know how to work with different data types. If you try to mix different data types, it can sometimes throw an error. As always, the computer tells us the cause of the error. It's like a little clue to help you improve your programming skills. Read the errors carefully, understand what they're trying to tell you, and use that knowledge to fix the mistake. In this example, the last line of the error message says, "We've encountered something called a type error. 8 is being read as an integer and 9 is being read as a string because of the quotation marks. No wonder we got an error. You can't add 8 to a word." This is important to know that some types can interact with each other while others cannot. Our next type is the Booleans. Booleans, or bools for short, are always either true or false, and are often used for binary variables with conditions like yes or no. Binary variables can only have two possible values. For example, did the client make a purchase within 1 month of receiving our email? They either bought something within 1 month or they didn't. Here you can see we assign a variable is customer equals true. We can see that true come out. And we assign is green equals to false. And we can see here we get that false. And finally, we have a special type called the none type. The none type is special to Python. There's only one possible value for an object of this type, none. In Python, you can see none appear in a lot of places, but in data analysis, you'll often see it to know that there is no data. For example, we have our nothing variable equal none, and when we print that out, you can see none is printed out. Note, this is different from a string. You'll also see it frequently with functions, since some functions will turn none instead of a value. As a data professional, you'll often need to aggregate a lot of data of different types. This will require converting the various types, so they can be combined successfully. There's an effective method for doing this. But first, it's important to know what you're working with. Python offers a helpful way to identify data types with the type function. You can use the type function to have the computer tell you the data type. For instance, the type function here tells us that P belongs to the str class, which is short for string. The number 5 belongs to the int class, or integer, and 4.8 belongs to the float class. And then a Boolean, you can see here it as equals to true. We see the type as bool. Now let's find out how to combine these different data types. There are two ways to convert data in Python. First is implicit conversion. Implicit conversion automatically converts one data type to another without user involvement. Here's an example. An arithmetic operations involving both integers and floats. The interpreter works in the background and converts integers to floats. You don't have to specify anything in your code to do this. If you want to convert numerical values to strings, you will need to do an explicit conversion. Explicit conversion is where users convert the data type of an object to a required data type. We use the predefined functions int, float, and str. This is sometimes called typecasting because the user casts or changes the data type. Let's use the str function inside the string we want to have interpreted as output. And now the output of this calculation will be stored as a string. There's a special function for each type. Let's go to our first type, which is integer. Here's a string with quotes around the number 2. This again is just a string type. But if we cast it with the int function, we see we actually get an integer, just the number 2. We can do the same thing with a float, where we have a float of 3.2. We're going to cast that into an integer, and we can see it gets a 3. And we can also do this with a Boolean. We can take a Boolean value, in this case true, and cast it into an integer. To turn something into a string, we can use the string function, or str. Here we have the number 2 integer, and it'll be converted into a string with just quotes around it. Similar with a float with 3.2 here, and then we can see the same thing happens with a Boolean, where we get the string version of that, which is just false. Now, to cast something into a float, we can use the float function, and you can see here, we can take an integer and convert it into a float. We can take a string and convert that into a float. And then we can take a Boolean and convert that into a float as well. Finally, we can cast values into a Boolean by using bool. So we can see we have bool, where we have an integer 0, and that ends up being false. If you have bool of a float here, and this gets negative 0.2, we have true, and then bool of a string, we have true as well. Note that when we have bools, when we're casting, we can basically convert these into one of 2 values. It will either be a true or false. Great work! Debugging, or figuring out what's wrong when your code won't work, is a really useful skill for any data professional. Also, as a final tip, all of us in the profession, even experienced data professionals and code developers, search for answers online when we encounter an error. This is a common strategy and a huge time saver. Always look to the data community for answers and inspiration. That's all for now. Don't forget to smash that like button, subscribe, and ring the bell to stay updated. In the next video, we will learn about Python data structure. Thanks for watching, and see you soon.